Yo, welcome to Physics with Vinay. Hi, I'm Vinay and I'm back. This is season 5, episode number 3 from the Rare series. और इस एपिसोड में मैं एक क्वेश्चन ऐसा डिस्कस करने वाला हूँ जो मैंने थोड़े दिनों पहले कम्युनिटी पोस्ट पर डाला था. And it was supposed to be a simple question, but surprisingly only 9% of the people who voted the answer got it right. So I decided to make this video because I thought it was necessary. So just take a look at the question. अगर तुमने नहीं देखा already, so just take a look at the question. This language is very simple, and try it out for yourself, and then take a look at my solution and what I do. Alright, so the question is कि एक पार्टिकल को प्रोजेक्ट कर दिया गया है किसी एंगल पर, एंड इन एडिशन टू ग्रेविटी उस पर एक रेजिस्टिव फोर्स भी लगता है. जैसे कि अगर तुमने फ्लूइड मैकेनिक्स पढ़ा है तो उसमें स्टोक्स लॉ वाला फोर्स जो लगता है प्रोपोर्शनल टू वेलोसिटी, वैसा वाला कुछ फोर्स लग रहा है यहाँ पर, या कोई एयर रेजिस्टेंस है, जो भी है. द पॉइंट इज दैट देयर इज एन एडिशनल रेजिस्टिव फोर्स दैट इज प्रोपोर्शनल टू वेलोसिटी एंड इट्स एक्टिंग ऑपोजिट टू द वेलोसिटी वेक्टर. ठीक है. सो द क्वेश्चन दैट आई हैड आस्क्ड इज what can we say about the angle that the acceleration makes with the vertical? Does that angle change? Does it increase, decrease with time, remains constant? So the answer is that it remains constant. The acceleration direction is a constant throughout the motion, and it is not obvious at all. So, and majority of the people did not give the right answer. So let's see how to tackle this kind of a problem and how to do it in a way that does not in the fastest possible way. Okay. So सबसे पहले तो can I write my net force would be mg, and let's say कि जो resistive force है is some minus kV, where k is a positive constant. So this force is proportional to velocity and it's opposite to velocity. ठीक है. So mg minus kV is ma, just force equation लिखा है, right? So my acceleration would be g minus k by m times v, right? ये मेरा acceleration हो गया. Now I'm going to do this in vector form. Majority of the students who would have tackled this problem या तो बिना calculation के किए रहेंगे, कुछ logic सोच के, या फिर they would have tried to do it in components, x component, y component, then take tan theta ay by ax, उस angle को देखेंगे. So let me just show you the quickest way to get to the answer for this kind of a problem is just stick to vector form. The acceleration is g minus kv by m. Now I want to see what happens to the angle that the acceleration vector makes. मतलब जो vector है acceleration का वो किस तरीके से rotate हो रहा है वो चाहिए मुझे. So let me, this is the key to this problem is the next step. Let me just differentiate this once again. तो dA by dt आ गया मेरे पास, g तो constant है, उसका derivative 0 minus k by m. Let me write k by m को कुछ और variable बोल देता हूँ, बीटा बोल देता हूँ. ठीक है. So minus beta times velocity का derivative right hand side पे कितना हो जाएगा, acceleration. Now this equation will tell you everything you need to know about the acceleration. This equation dA vector by dt is minus beta a vector. You look at a vector. Initially एक resistive force opposite to velocity है और gravity नीचे लग रहा है, तो कुछ इस तरीके से net force होगा. तो a vector would be initially this way, right? Resultant of gravity and the resistive force. ये a वेक्टर होगा, राइट? नाउ dA by dt is नेगेटिव ऑफ बीटा टाइम्स a. मतलब dA by dt, a वेक्टर ऐसे है तो dt टाइम में dA वेक्टर उसके ऑपोजिट है, करेक्ट? तो दिस इज द चेंज इन द वेक्टर. इट इज एग्जैक्टली अलोंग द सेम लाइन एज द एक्सेलरेशन वेक्टर बिकॉज dA by dt is minus some scalar times a vector, right? So the change in a vector is always along the same line as a vector. तो ये क्या होता जाएगा, a वेक्टर का मैग्नीट्यूड कम होते जाएगा बिकॉज dA वेक्टर ऑपोजिट डायरेक्शन में कम होते जाएगा. विल इट चेंज द डायरेक्शन कहीं बिकॉज द एक्सेलरेशन वेक्टर इज डिक्रीजिंग, मैग्नीट्यूड इज डिक्रीजिंग विद टाइम. विल इट चेंज द डायरेक्शन? इस सॉल्यूशन का, इस डिफरेंशियल इक्वेशन का सॉल्यूशन बहुत ही स्ट्रेट फॉरवर्ड है. दिस इज जस्ट अ वेरी स्टैंडर्ड डिफरेंशियल इक्वेशन. इसका एक्सेलरेशन, जिसका सॉल्यूशन विल कम आउट टू बी सम a naught into e raised to minus beta t, right? The first order equation. So what is a naught? A naught is the initial acceleration. So what is going to happen is कि a vector is always parallel to a naught vector. The equation tells us. इसका मतलब क्या? the direction of acceleration is always a constant. That's it. That's the answer to the problem that I had asked. कि acceleration का direction is always a constant with time. It's very surprising result क्योंकि obvious नहीं है. Starting में ऐसा लगता है velocity change हो रहा है तो resistive force change होगा, velocity का direction change हो रहा है, इसका direction भी change होगा, resultant acceleration. It's not obvious कि उसका direction constant रहेगा. ठीक है. So the whole key to check this was to calculate the change in A or the rate of change in A and see what it does. ठीक है. Because the rate of change of A is opposite to A vector, A vector उसी line के along कम होते जाएगा बस, मतलब उसका direction fixed हो जाएगा. ठीक है. What is A naught? A naught is the initial acceleration. Initial acceleration क्या है? Initial velocity V naught अगर है तो G minus beta V naught. ठीक है. मैंने K by M को beta रखा है. तो initial acceleration जो है, let me call it A naught. Okay. Alright, so the problem is solved, but let's just go a little deeper into this analysis and let me show you कि इस तरीके से जो problem है जहाँ पे एक resistive force है proportional velocity, उसमें they can ask you other things also. They can ask you find velocity as a function of time. They can ask you find the displacement as a function of time. ये सब भी पूछा जा सकता है. So in that case, how to do it in the fastest manner is keep sticking to this vector form. Acceleration को अगर मैंने integrate किया, acceleration को dv by dt लिख सकता हूँ, dt को right hand side पे लेके जाता हूँ. A naught तो constant है, initial V naught, finally V. So V minus V naught, e raised to minus beta t, 0 से t, ये आ जाएगा, right? E raised to minus beta t का integral is e raised to minus beta t divided by minus beta, limit 0 to t. Okay, so velocity vector आ गया टाइम के साथ. तुमको अगर कंपोनेंट्स पूछा है तो यू कैन टेक द कंपोनेंट्स अगेन. यू कैन राइट v naught in terms of I cap, J cap, A naught in terms of I cap and J cap, or A naught in terms of this. But otherwise, you don't have to do I cap, J cap right in the beginning because the vector form is very very easy. ये मेरा पूरा वेलोसिटी वेक्टर आ गया, राइट? इसको इंटीग्रेट करूंगा तो मुझे क्या मिलेगा? डिस्प्लेसमेंट वेक्टर मिल जाएगा. v naught कांस्टेंट है, v naught into t प्लस A naught by बीटा. V naught प्लस A naught by बीटा पूरा ही कांस्टेंट है ना. एक्चुअली इसी को मैं थोड़ा सा इधर सिंप्लीफाई कर सकता हूँ क्योंकि A naught is G minus beta V naught, right? So A naught is G minus beta V naught. तो ये V naught और एक माइनस V naught यहाँ पे कट जाएगा, बचेगा बस G. So let me write it as G vector by beta plus माइनस A naught by beta e raised to minus beta t. इस वेलोसिटी का ऐसे सिंप्लीफाई कर रहा हूँ मैं. ठीक है. I've just substituted A naught as G minus beta V naught here and cancelled out V naught, and A naught by beta is the multiplier. Again you can substitute A naught here also. Okay, so displacement vector कितना हो जाएगा? Just integrate this. ये velocity vector है. G तो constant है, gt by beta minus e raised to minus beta t का इंटीग्रल is e raised to minus beta t divided by beta divided by minus beta. तो यहाँ पे प्लस बीटा स्क्वायर आ जाएगा. 0 to t लिमिट्स लगाऊंगा तो ठीक है. तो यहाँ पर एक नेगेटिव साइन हो जाएगा, राइट? ठीक है. नेगेटिव साइन जस्ट चेक कर लेना, मैंने कैलकुलेशन सही किया. बट द होल पॉइंट इज दैट you can easily get displacement, velocity and even acceleration just by sticking to the vector form without having to do it in components. Okay, so अगर question में आया तो just do this process and you can easily get. अभी अगर finally पूछा गया find the horizontal displacement, then just take the x component of this equation. वो तो काफी straightforward. Alright, so that's what I wanted to do in this video. I came up with this video only because बहुत कम लोगों ने correct answer दिया था, so I thought it is necessary to come up with this video. I hope you enjoyed this episode from the Rare series, and I will continue uploading more such episodes with a greater frequency. So I hope your studies are going well. That's it for today. I'll see you at the top.